Good morning, folks. I have here a first 5-minute question for you to start. It's just based entirely on yesterday's lesson, and I'm asking you to solve for side M. And remember, we always take the angle M and label across. So you're looking for this side here. So I would love for you to pause it, try it, and then unpause it to see how you did. Okay, so here's hoping that you tried that. All right. So first of all, this is our reference angle, right? We always go with the angle we know. Technically, you could find this angle by subtracting from 180 and then work from there. But if we're going to do it this way, first of all, we have the opposite side. And we're looking for this side here, which is not the hypotenuse. And it's obviously not the opposite because we already have that. So it must be the adjacent. So then what I do is I write down SOHCAHTOA. And I look for the one that has O and A for opposite and adjacent, and that is going to be tan. So we have tan of our angle equals the opposite, which is 28.9, divided by the adjacent. Remember, that comes from TOA here, and that's going to be M. Now, our angle is on the bottom, or our unknown is on the bottom. It's actually a side, not an angle. So we switch these two. So M comes up, and that equals 28.9 divided by tan of 68 degrees. And from here, it's just a calculator problem. So we do 28.9 divided by, and again, on my one-line calculator, I have to hit the angle first. I don't forget to hit equals, and I get that M is approximately 11.7 meters. And then I just look at my diagram to see if that makes sense. And it looks a bit weird here, right? Like this side looks like it should be longer than this. But if you look at the angle, I've labeled this as 68, but in reality, it's nowhere near 68. I bring my protractor in here, line it up, and make it nice and big. We can see that that angle's from here we go 10, 20, it's not even 30 degrees. So the angle is not really how I measured it. So this makes sense. Okay, so this is the answer here. This angle should be a lot bigger, which would make this side smaller. And that's our answer, 11.7. Okay, moving on to today's stuff. So far we've used sine, cos, and tan to find the measures of sides. Today, we're going to use it to find the measure of angles. And honestly, if you can do yesterday's stuff, you can do today's. It's just one extra button on your calculator. So what I'm going to do first, I'm just going to set this up here. Now I'm giving you two sides, which is a little bit different. But what I want you to do is to think about, would you use sine, cos, or tan, remembering SOHCAHTOA. So would you use sine, cos, or tan to solve for the angle that I say here? So this is angle A. So here's angle A right here. If these are the sides that you have, I want you to take a moment and think about this. I haven't taught you yet, but I think you have the tools to do this. And all I want you to do is, which one would you use? Sine, cos, or tan? All right, I'm hoping that you paused and tried that. If you didn't, try it now. So if this is our angle, we have the opposite. We have the hypotenuse. So we have O and H. So I look at my SOHCAHTOA for O and H, and in this case, we have O and H, which goes with S, which means this one would be sine. Okay, and then I've got some steps here which you can look at. Let's try the next one. Now we're looking for the measure of angle B. So here's angle B, here's SOHCAHTOA, and I would love for you to pause and try to figure out which one you would use. Okay, so in this case we have the hypotenuse, obviously. And we don't have the opposite, so we have the adjacent. So I'm looking for A and H. A and H is cos, so I would use cos. Okay, pause and try to figure out which one you would use here. All right, so we're looking for angle C, it says. So this is angle C right here. Sorry, my pen thing's not working. This is angle C. So we have the opposite slash hypotenuse, and this doesn't work. Excuse me. So we can't use the 90-degree angle. Remember, it doesn't work. So this is impossible. So skip it. Next one. Angle A, I'll bring in SOHCAHTOA again. Pause. Just figure out which one you would use. So in this case, we have the opposite. We have the adjacent. We're solving for an angle, which you don't know how to do yet. We're just looking at the setup. So we have O and A, which is TOA. So we would use tan. Next one, we're looking for angle B. Make sure it's not the 90, and it's not. Pause, give this a shot. So we have the opposite, and we have the adjacent. So O and A are the things we have. That's TOA. So in this case, we would use tan. Okay, two more, and then we'll get into today's lesson. And so if you're a bit lost right now, don't worry. I think once we get to the lesson part, things should sort of iron out for you. All right, determine the measure of angle A. That's this angle here. Please pause and give it a shot. So we have the hypotenuse. We don't have the opposite, but we do have the adjacent. So A and H is cos. So we would use cos. All right, last one. Please pause it and try it. Angle B. Here's angle B. We have the opposite. We have the hypotenuse. O and H is sine, so we would use sine. All right, so I'm going to skip this part. This was more of an investigation for class, so we'll jump right in. All right, so here's your note. To solve for an angle in a right triangle, 1, label the sides. 2, decide if you're going to use sine, cos, or tan using SOHCAHTOA. This is the most important step, because if you get this one wrong, then everything will be wrong. Step 3, set up the ratio. So set up sine, cos, or tan. Plug in your values. And here's the hard part. Here's the new part. It says use the inverse button to solve for the angle. So let me show you how that will work. All right, what's inverse? Well, in this case, so we have sine A equals 3 over 5. This just means that for some angle, A, the ratio of the opposite to the hypotenuse is 3 over 5. So this would tell us that in this case, our opposite is 3 and our hypotenuse is 5. So yesterday, we had the angle that went here, so we would just type sine angle. But this time, we're solving for the angle, so it's a little bit backwards. So what we have to do when we have an angle, so that was yesterday, we use the normal buttons. But today, when we want the angle, we use sine -1, cos -1, and tan -1, which really is sine inverse, cos inverse, tan inverse. And if you're still lost, don't worry. We're going to do a couple of examples right now. Here we go. We're just going to use our calculator to start here. So if I'm told that sine A is 0.627, so that this tells me the ratio of the opposite to the hypotenuse, we want to find angle A. So check this out. I type 0.6027, and then instead of sine, cos, or tan, I'm going to use inverse sine, cos, or tan. So I hit second function, and then I go and I hit sine. And that didn't work. All right, so how do I do it on this calculator? Sorry, this calculator changed for me recently. So go to scientific. Oh, here we go. Yeah, so I use the second button in there. So I'll type 0.6027. I go to my trig functions, and I want to use sine, but I'm looking for the angle, so I hit second sine. And there we go. And usually for angles, we do them to approximately the whole degree, so 37 degrees. I'm going to do one more, and then I want you to try the other one. Well, I'll do two more. So cos A equals this, so 0.6129. And instead of hitting cos, we have to do second cos, and we get 52 degrees. So A is approximately, that should have been approximately as well, 52 degrees. Next one, tan A equals 3 over 4. So this one looks a little bit weird. So what I do this time is I hit 3 divided by 4, and that'll give me the decimal. In these other ones, I gave you the decimal already. So 3 divided by 4, and then I do trigonometry, inverse sine or second function sine or shift sine on some of your calculators. It's going to be really important before you move on that you find how to do this on your calculator. So second tan is about 37 degrees. So A equals about 37 degrees. Next one, 2.5421. It's sine, so I do second sine. Oh, and I get an error. So this is something that happens when you've made a mistake. So you'll notice here that for sine A, we have that it's a number bigger than 1, which you can see we don't usually have with sine or with cos. And that's because remember that sine of an angle equals the opposite over the hypotenuse. Now let me ask you, which one of these numbers is always bigger? Is the opposite always bigger, or is the hypotenuse always the biggest side? And hopefully you remember that the hypotenuse is always the biggest side. And if you have a number divided by a bigger number, so let's do like 3 divided by 6, 0.5. 3 divided by 2. Well, now I did a bigger number on top, and I got a number bigger than 1. So let's stick to small on top. So 1 divided by 2, 0.5. 1 divided by 3, 0.33. 2.6 divided by, let's just go a little bit bigger on the bottom for the hypotenuse, because we know the hypotenuse is bigger. I get 0 point something. So what I want you to keep in mind here is that sine or cos of an angle is always less than 1. If yours is more than 1, you made a mistake. Okay, so in this case, if we have sine of an angle is bigger than 1, we just say error. It doesn't work, impossible, can't be done, whatever you want. And now the next one we have is tan, and this number is a lot bigger than 1. So let's try this out. So we go second tan, and I get 88.98, or approximately 89. A equals approximately, if we round, it's 89.0 degrees. And you might be wondering, well, why is it okay for tan to be bigger than 1? Well, remember, tan of an angle, or an angle, is the opposite over the adjacent. Now, think about it. In a triangle, is the opposite always bigger? Is the adjacent always bigger? Or can it be either way? And it can be either way, right? The opposite and the adjacent, one can be bigger than the other can be bigger. It doesn't matter. So tan can be bigger than 1. Okay, so let's get into the questions. You don't have to worry too much about this part here. You're just going to find when you're doing this, things usually just work out. Okay, so we're asked to determine the missing angles. It doesn't matter what order we do. We know that this one's 90, which again, in this unit, we always need a 90-degree angle. So let's solve for angle P. I'm going to write angle P. So here we go. This is the lesson. If you haven't paid attention or you've been lost till here, this is the part where you really want to watch what's going on. So if this is angle P, this is my opposite, because it's across from P. We don't know the hypotenuse, so this is the adjacent. And now we set it up. Tan, because opposite and adjacent. Remember SOHCAHTOA, O and A tells us it's tan. So tan of my angle, which is P, equals the opposite over the adjacent. Now I go to the calculator, and I can be done this in one step. So 10.2 divided by 13.1 equals, so this is tan P equals this number, and if you want, you can write this number down, round it to 4 decimal places, but we can do better than that. Once we have the number, we just go here and we do second tan, and we get about 38 degrees. So you could have done it like this though. Tan P equals, so it was 0.7786, And obviously I've rounded, so I'll put my dot here. So now what we can do is we can say 0.7786. And now P is going to be inverse tan of 0.7786, approximately, because we rounded. And now I go to the calculator and I do second tan. And again, I get about 38 degrees. So it doesn't matter if you do it this long way or if you just go from here to the answer. And I encourage you to just jump to the answer because this is a lot of extra work. And when you round the number, your answer is not going to be exact. So I'm going to write here this. These two steps are unnecessary. Okay, so we've got angle P. Now, if you know this is 90 and this is 38, how would you find the other angle? Well, I'm hoping that you remember the sum of the angles in a triangle is 180, so you do 180 minus 90 minus 38, and you get 52. So this means that angle Q is approximately 52 degrees. Now, if you didn't remember that, you could just use trigonometry again. So now, let's do angle Q. And for angle Q, I'm going to do everything in blue. So here's our angle, which means now this is my opposite. You'll notice that when it was P, it was adjacent, but now that we're up here, this becomes the opposite, and this becomes the adjacent. So if we're dealing with O and A, we're dealing with tan. So tan Q equals the new opposite, which is 13.1, divided by the new adjacent, which is 10.2. We go to the calculator. I do 13.1 divided by 10.2, and I get this number. Now, if you have a two-line calculator, you can just type second tan bracket 13.1 divided by 10.2, and I'll write that down in a sec. So now I do second tan, and I get 52 degrees, which is the answer that I got by subtracting from 180. So again, for my two-line calculator people, you would type this. Second or shift tan bracket 13.1 divided by 10.2, close the bracket, hit equals, and you're going to get your answer right away. So make sure you go through these a couple of times on your calculator until you get them. Because once you can do this, you can do every example from today. All right, next up, determine the missing angles. We'll do angle K first. So if this is angle K, this is my hypotenuse. It's the longest side. This is the opposite, but we don't know it. This is the adjacent. So let me bring my SOHCAHTOA in here if I still have it copied, and I do. Okay, so if we have the adjacent and the hypotenuse, A and H is cos. So cos K is the adjacent, 24.5, divided by the hypotenuse, 27.3. And then I go to my calculator. And I do 24.5 divided by 27.3 equals, again, two-line people, you might already be done. And now I do second cos, and that's it. I get 26 degrees. So K equals approximately 26 degrees. And now to find angle E, I'm going to do it the quick way. I could go up here and opposite hypotenuse and use sine, but I know that we just subtract from 180. So 180 minus 90 minus 26. So E is going to be approximately 180 minus 90 minus 26. Oh, sorry, I did something weird. 180. Oh, all right, 180 minus 90 minus 26 is 64 degrees. Now, there's another shortcut. Last shortcut that I'm going to give you. What's 180 minus 90? Well, 180 minus 90 is always 90. So what you're going to notice is that these two angles always add up to 90. So once you have one of them, you can just do 90 minus the one that you have, and that'll give you the other one. Okay, moving on. All right, determine the measures of the missing angles. We'll do angle A. You can do angle Z first. It literally makes no difference. If we're going to do angle A, this is the opposite, this is the adjacent. We look at our SOHCAHTOA to determine which sides we're going to have here. Okay, so O and A is TOA, or tan. So tan of A equals the opposite divided by the adjacent. I go to my calculator, 6.1 divided by 9.3 equals, and then I'm going to do second tan because I'm looking for an angle, and I get that A is approximately 33 degrees. And then for angle Z, I know that these two angles add up to 90, so Z is going to be 90 minus 33. Ugh. I don't know why that keeps happening. Stop it. 57. Z equals approximately 57 degrees. And we're done. But again, if you didn't remember the 90 minus thing, you could just go to angle Z. This would now be your opposite. This would be your adjacent. So tan Z, because we're dealing with O and A, is 9.3 divided by 6.1. So 9.3 divided by 6.1 equals, and then I do shift 10. And I get 56.7, or about 57 degrees, which is the same as what I got the easy way. So remember, it doesn't matter how you do it, you'll still get the same answer. Sometimes if it's like 0.5 or 0.4 or 0.6, it could be a little off just because of rounding, but that's okay. All right, that is it for me. I want you to try this homework here, and again, I'll post the solutions later on today. So this tricky one here, I ask you to draw the triangle, and I'm just going to draw that for you. Angle J is 90, okay? So this will be P, and this will be B. So side P is 55. Oh, let me switch those. So J is 90, P is 55, B is 21. So I'm going to make this B because this side is shorter. It doesn't matter at all. I'm just trying to make it a little more realistic. And P is 55. And then you're supposed to find these two angles. Okay? And then there's more practice. And so what I would like to do here actually is, for this you try part, I want you to pause and try it, and then unpause and watch my solutions. Okay, so angle G. So we've got the opposite and the adjacent. And if we're looking at SOHCAHTOA, this would be tan G is the opposite divided by the adjacent. I go to my calculator, I do 51.8 divided by, not times, divided by 100.1 equals, and then I do second tan, and I get about 27 degrees. And then we know that angle S is going to be 90 minus 27, approximately, because we rounded already, 63 degrees. And that one's done. Next one. Again, I'm hoping that you paused and tried this. So angle M, we've got the hypotenuse, we've got the adjacent, and hopefully you're getting good at knowing whether it's sine, cos, or tan. You should have SOHCAHTOA memorized. So if we have adjacent and the hypotenuse, it's cos. So cos of M equals the adjacent, 30.7, divided by the hypotenuse, 43.4. And we do 30.7 divided by 43.4 equals, we're doing sine or cos, so it's got to be 0 point something. Second cos is about 45 degrees. And then for angle S, it's going to be 90 minus 45, or 180 minus 90 minus 45, and we get approximately 45 degrees. Okay, moving on. These are the last two I'm going to do with you, and then the rest will be homework. that I will post answers to. So let me bring SOHCAHTOA in here. I always recommend writing SOHCAHTOA first. So for angle Z, this is my opposite. And be careful, the triangle's upside down. This is my hypotenuse. If we're dealing with O and H, it's sine. Sine Z is 7.7 over 15.9. I know I'm going to round because these things never work out as nice decimals, or usually don't. Once in a while you'll find they do. I hit equals. And then I'm doing sine, so second sine because I'm looking for an angle. And I get Z is approximately 29 degrees. And therefore, angle P, which is, angle A, angle P is 90. So angle A is 90 minus 29. So angle A is approximately 61 degrees. All right, for the last one that I'm going to do with you, I've drawn the triangle here. Let's find angle P first. This is the opposite. This is the adjacent. If I'm dealing with O and A, or A and O, I'm dealing with tan. So tan P equals the opposite over the adjacent. I go to my calculator. 55 divided by 21. And then I do second tan, because I'm using tan, and I get that P is approximately 69 degrees. And then for angle B, it's going to be 180 minus 90 minus 69, or 90 minus 69. And B is approximately, so 90 subtract 69 is 21 degrees. So B is approximately 21 degrees. And that's it, folks. So if you have questions, please do get in touch with me. People struggle with this because of the second button, the shift or the inverse, whatever you want to call it. So do get in touch with me if you need some help. Otherwise, good luck. And yeah, thanks for continuing on through this crazy time. We got about a week and a bit left, and then it's all over. Okay, talk to you later.